Today we discuss about the rotational motion. First we go on the chapters involved here. A part is, you can say, introduction. It involves many motions you observe in the life, and it also includes axis, concept of the axis we know. Second part is center of mass. Third, we discuss about the moment of inertia, like the inertia of the Newton's law of motion. Then we discussed about the torque. That is the force of rotation. We go about the angular momentum, their conservation also. Then we go to discussion of the rolling motion in details. Then we discuss about the acceleration during rotation. These are the major part we have to know about. In the section of introduction, I am trying to ask one thing from you. So, which motion takes place more in the inverse? Think about it and tell me. Straight line motion or rotational motion? Which is acting more in the inverse, in the nature, in the Brahmand, you can say.
जैसे अगर हम रोटेशनल मोशन में घूम रहे हैं तो फिर वहाँ पे जो डायरेक्शन होगी वो टेंजेंट वाली होगी, तो लीनियर मोशन अलग होगी.
On the road, on the park, on the Delhi, on the anywhere, we see more linear. But in the nature, one star is rotating around the other star. है ना? So all stars are rotating. X star, Y rotates around the X. Correct? Around the sun is also star. Many planets are rotating, including the earth. We are living on the earth, so we are always rotating. Correct? So in the galaxy, earth is very large, but it acts like a point mass. So in the nature, rotational motion is very excellent acting in the nature, but This is very simple about the rotation, because every body want to rotate, remain in the rotation motion. Usually teacher of science and physics tell that rotational motion is very difficult. I am telling you again that this is the simple motion. This is very simple form of strategy to understand it and calculate it. In place of calculation, in the first chapter, I defined that physics is the science of measurement that make our life easy. So come to the part of introduction. I introduce you with the linear motion. Again, translatory motion, again circular motion, thereafter about the rotational motion, then rolling motion, and sliding motion. If I discuss all this, then we discuss about the axis of rotation. Many axes of rotation. So two things, rotation, I discussed today. In the form of intro of this chapter, and all these are very important to learn or understand it. First one is linear motion. You know, this is one-dimensional motion. This is also motion in a straight line. I take here a particle. So what do you mean by the particle? Particle means there is no length, no breadth, no thickness. So this is called what? Particle. When a particle moves from one place to another place, this is called what? Linear motion. Again, I am telling that there is one stop, one spot. There is second spot. This spot is New Delhi railway station. This is Mumbai terminal, Mumbai railway station. If a train moves from the New Delhi to Mumbai, so this train is considered as what? Third spot, third particle. So third particle move from the one stop to second stop. This is also is what a particle. New Delhi, Mumbai, and train. All three are considered as a particle. But if there is an overbreeze, and if train of 10 bogies pass through the overbreeze, and if the train of 15 bogies pass from the overbreeze, what will happen? A smaller length take a small time to pass the overbreeze. Larger is length, it may take more time to cover the bridge. So there is time less, there is time more, and two trains are here. We consider that both are what? Bodies. So linear motion, usually we consider the train, the aeroplane, the helicopter a particle. So this is the concept of what? Linear motion. Write down. Linear motion you know very well. Second, I discuss here about the system of particles. This is also called body. This is also called rigid body. In this case, there are many particles. Particle number 1, 2, 3, 4, 5. Many particles are there, and all these are bounded by, attracted by the force which is called intermolecular force. So all these particles are not in motion, not separated due to the force, you know, intermolecular force. This duster, all particle of this duster is at rest. When I apply force on this duster, all particles move together without separation of the particles. So I apply force, all system of particle, all particle here moves. and velocity and acceleration is same for the all particle here, particle middle, all the have same velocity and same acceleration. So you can define it all the particle have common separation and when force is applied every particles has same velocity and acceleration. So this is the property of the body or rigid body. See here, or rigid body. Suppose in this rigid body there is particle A, there is particle B, there is particle C, there is particle D. Again see the motion of this rigid body. Rigid body. When you apply force on this rigid body, what will happen? Rigid body, suppose come here on this point, on this place. So A come at the same position A, particle B come at the same position B, particle C come at the same position C, and particle D again the point D. So this motion of rigid body, a system of particle, it is called, this motion is called translatory motion, or you can say translational motion. So this is the character of system of particle. Translational motion. No change in position of the particles. Again we discuss about the circular motion. In the brief, you studied, there is a particle that move in the circular path. at the fixed radius. No change in radius here. Radius remains fixed. So from the particle is P here, goes to this point. Again, time taken is 1 second. In this case, when particle move from this point to this point, angle is how much made? Theta. So theta is what? Angular displacement. Theta is angular displacement. Which is the vector quantity. So I write here that this vector quantity is written as theta, making arrow over there. So this is the displacement. Again I am writing here, since it has taken time t, there must be what? Angular velocity. Angular velocity. This is what? Omega. This is equal to angle made or displacement traveled by the time taken. Time is how much? In the general unit, according to the units and dimension or formula of the physics, is measured in 1 unit. So this is 1 unit in the radian. This is time in second, 1 second. When this particle move on the circular path, come back the point P. So this is called time period. Time period is what? See here, particle starting motion from the point P or come back to the same point. This is what? Time period. So this symbol is capital T. That is what? Time period. For the complete motion. And what is frequency? If particle rotates 10 times, 20 times, 30 times in 1 second, that is called frequency. Frequency, its symbol is nu 1 upon time period. In 1 second, how much rotation takes place of the particle? So circular motion is basically motion of one particle, not second particle, not third particle. So car is moving in the circular path. This is a particle. In the galaxy, Earth is moving. It is also considered as a particle. Stars are moving around each other. That is also what? Circular motion. Now let's discuss about the rotational motion. there is a body, system of particle. You can see one particle is moving like that and complete the circular path, and this is the center. Again particle move like that and come to again this point. This is the center. Third particle also move like that. This is the center. So one particle, two particle, three particles move, and center of all the particle is common. This is called what? Axis, or you can say axis of rotation. Axis of rotation. In the circular motion, we discussed center is not moving. Center is what? Static. Here is center static. Here is center static. Again, there is no separation of this particle and this particle. All three particles are not changing distance and move in the same time. Same rotation, speed is there. So constant time, constant speed of rotation the all the particle. This is called what? Rotational motion. When more than two particles, system of particle rotate around the common axis, this is called what? Rotational motion. So a motion in which more than two particles rotates around common axis. Common axis. You know, there is no changing. All particles has same angular velocity. Omega is common for all. If the same body, system of particle come here, same system particle, then one particle rotate here. This is called what? Linear motion. When this center, suppose this particle come here, this is called translatory motion. center of the body not changing, like that of rigid body. That was what? Translatory motion. Again, suppose here a particle rotates on this center. A particle rotates on this center. This particle rotates at this center. So there is what? Common axis of rotation. There is what? This is called rotational motion. So I revised everything. Linear for the one particle, linear for the center of mass, and translatory for the center of mass, and rotational if many bodies rotate along the common center, along the common axis. Again, there is wheel of the car. There is point A, there is point B, there is point C. It rotates. Suppose at this point there is point A, there is point B, there is point C. So A come down on the bottom. So this type of motion on the road of the car or wheel, what is it is called? This is along the center. Center move from one point to other point. This is what? Translative motion. And particles rotate in the diameter. That is called what? Rotational motion. So translatory and rotational motion both takes place here. This is called rolling motion. This is the general language. Rolling of the wheel with involved center of mass motion, that is translatory, rotation along the diameter, this is what? Rolling motion. So we discussed about the linear, circular, translatory, rotational, and again combination of translation and rotational motion is what? Rolling motion. Rolling of the car wheel. Now see here, a body is here. On the surface or road A, B, C, D. At this place again A, B, C and D. Again at this place A, B, C and D. So what happens here? Base of the surface, particle on the surface C, particle on the surface C, particle on the surface C, not changing. This is what called? This is the sliding motion. So four types of motion: linear, translatory, circular, rotational, rolling, and sliding motion we discussed. Again you can see that the body is same. Body is same. A, B and C and D. If it rotate like this, come here on this position, this becomes, suppose here is A, here is B, here is C, here is D, and such rotation takes place on the surface, then this is what? This is again rolling motion. Correct now? So this is moving at this place and all particle move along the diameter. क्या हो जाएगा? Translatory plus rotational. That is called rolling motion. Correct now? So we learned about the concept of motion in the different forms, different ability, different capacity, different uses, applications. Now we discuss about the axis of rotation. Again see here, a system of body. There is a particle rotate like this. There is another particle rotate like this. This is the center. Again a particle rotate like this. Another particle rotate like this. Another particle rotate like this. There is center. Again there is a particle rotating here. There is center. So all these centers are joined. This is what? Axis of rotation. Correct? So I am writing here axis. Axis means many axes. Axis of rotation is the line drawn from the center of rotation of all the particles in rotational motion. Rotational motion. Correct? Again, we see here what tells about the axis. This duster is a axis here, and this is the ring or disc. So at the right angle, this axis is present here. So this gives what? Axis is what? Location, and this disc rotate along this. है ना. So direction of rotation, this is the axis, that is duster, and this is the disc. Disc rotates, so location of the disc is also found out. So axis is along the perpendicular of the disc, making what? Right angle. This axis is called what? Tangent. Correct? Huh? So this is a suppose disc, and this is the axis, and this rotate along the axis. So this is called generally tangential axis. Again see here, this is the diameter, so this can rotate along the diameter also, है ना. This disc can rotate along the diameter, axis like that, है ना, passing through the diameter. This can rotate along the diameter. So I am making here again disc, and this is the axis passing through the diameter. Axis along diameter. So we have to discuss about the many axes. So axis give what? Axis gives location and direction. Of rotation, you can see, or rotation of the body, you can say. So two concepts are developed by the disc, by the axis, basically location and direction. Now we see about the natural axis. What is the natural axis? This is disc, you know. I apply force on this disc and disc rotate. I apply force on this disc, it rotate. I apply force on this disc, and after applying force, I remove the force. Sometimes I applied force on this and this can rotate. So this is called what? Natural axis. Hana? And this disc may rotate along this diameter, can rotate along this diameter, this axis, this axis, this axis, this axis, any diameter can be here, correct? So vertical we consider what? Y axis. This is what? Y axis. क्या से this is the disk. This axis suppose vertical, it can rotate along this, है ना? Again this is y axis vertical, this is what horizontal axis x, correct? And if this disk rotate like this, so center is what? Z axis. X is upward, y is horizontal, z is towards you, positive z towards you and negative z inside the board. So x, y and z, all three axes is here in the found in the disk, you can see. So what is the natural axis? When you apply force on a body and remove the force, body goes in the rotational motion. So that axis is what? Natural axis. So I am writing here when force is applied on a rigid body and it is removed, then axis of rotation is natural axis. So this is suppose disk, there is y axis, there is x axis, there is z axis towards you, z positive. So this is what? Center of mass. So all natural axis passes through the center of mass. Every natural axis pass through center of mass. Everyone pass through the center of a mass. That is a condition fixed in the natural axis. Then we discuss about the principal axis. I think principal axis you know. to study, to think, to apply. Need of axis is very important. This is the book of R.D. Sharma. You know, if in the question it is given that this body rotates along the y-axis, so consider this is the y-axis, this is the y-axis, book rotates along the y-axis. If in the question body rotates along the width, so this draw line here, rotate this body like this. If it is written in the book, in the question, that body rotates along the diagonal, this part is what? Diagonal of the book. So draw a line here and rotate the book like this. Correct ना? ठीक है? तो this is y-axis, this is x-axis along the width, this is the diagonal like that. So focus on the axis, in which direction, in which location the body is rotating. That is why discussing about the axis, many axes about that. Next one is what? Principal axis. So you know x-axis, y-axis and z-axis. All these are what? At the right angle. X-axis, y-axis and z. Z-axis is towards you. So this is z-axis. All making how much angle? 90 degree. Correct ना? So all the axis x, y and z of Cartesian sign is principal axis at right angle. Next one is sense of rotation. Very important. Sense of rotation. So you know two types of rotation are there. It may be clockwise rotation. Clockwise rotation. Other rotation is what? Other is anti-clockwise. Anti-clockwise rotation. Clockwise we consider negative rotation. Anti-clockwise we consider positive rotation. So you can say also axis of rotation. Axis of rotation. So if a body rotate along the anti-clockwise, that is what? Positive rotation. If rotate along the clockwise, this is considered as negative rotation. So value of calculation is obtained from the axis. So all these are very important for the rotation. Correct?